Okay. So number 2, if our first goal is to get the A's to one side, what would we do to get the A's to one side? Subtract which one? To get the A's to one side? Okay, so you could subtract the 4A or the 3A. It doesn't matter. Okay. All right, so that would leave us with negative A plus 8 is less than 2. So if we want the A to be alone on the left side, how do we move the 8 over? Subtract the 8, okay? And at this point, since I'm getting started, I shouldn't see any earbuds, shouldn't see any headphones, no cell phones. 2 minus 8 is -6, okay? And then what do I do to get the A all by itself so there's no negative there? Divide by -1. That's what you meant. It was a typo. What happens when we divide by a negative? Becomes a positive. And then what happens with our symbol? It switches directions. Yeah, it flips. -6 divided by -1 is +6. And there's our answer. Yep. Yep, you can do it that way too. And then you end up with your A's on the other side. Yeah. Yep, that's another way to do it. Okay, let's go ahead and get started on our notes. So here we are over here. And Destiny, let's put the cell phone away since we're starting our notes. All right, so we have the vertex is the point where the graph switches from increasing to decreasing or vice versa. We know that the vertex is kind of like this point right down here or this point right up here. And we know that we can find the vertex by looking at these numbers right here. It's the opposite of the number inside the function. Quentin, I'm about to take that phone and check it out the door. Thanks. And it's this number on the end. So what is the vertex for the first example? -5, -6. Okay. What is the vertex for the second example? Yeah. 0, 1. Perfect. If we wanted to rewrite the second example so that it had parentheses, we could do that. We could say -2/5, and then we could write x plus 0 squared plus 1. That's where the parentheses would be, and that's where the number would be if they had put them in there. But since it was a 0, you don't really need the number. And then since there was nothing in there, then you don't technically need the parentheses. And so most math people would write it like this. But writing it this way is correct as well. Okay, so domain. If I'm looking from the left side of the picture, I'm going to use my first color. If I'm looking from the left side of the picture to the right side of the picture, because domain is my x values. Domain is my x values, so I'm going to go from left to right. What do I see on the left side? What do I see on the right side? Arrow on the left, arrow on the right. And so what number do I use for arrow to arrow? Yeah, I use infinities. I'm going to say my domain is from -infinity to +infinity. So domain is all the x values in the function, left to right. Let's look at example 2. Same thing, x values again. We're going to go from the left side to the right side. What do you guys think the domain is for the other one? -infinity to +infinity. Do you guys think the domain will ever be anything different? No. Nope. So the V-shape graphs from last unit and then the U-shape graphs from this unit, they're always the same. -infinity, +infinity. So that makes them kind of boring. Okay, next I'm going to look at the range, which is the Y value. So I'm going to switch colors. Y values for the range. So for the range, we go from the bottom of the graph to the top of the graph. So the bottom of the graph to the top of the graph, and we're using Y values. So what is the Y value at the bottom of the graph? -6. -6 is the Y value at the bottom of the graph. -6 is the Y value at the bottom of the graph. And then is -6 a number that I can see and put my finger on? Yes. So I'm going to put a bracket. Perfect. And then what do we see for the top of our graph? Positive infinity, because we have some arrows that are going up. And so arrows mean forever. So that's infinity. Okay. And remember, infinity always gets a parenthesis. Okay. Let's look at the next example. We're going to go from the bottom of the graph to the top of the graph. So the bottom of the graph is some arrows. The top of the graph is the vertex. So what should we put for the bottom of the graph? Negative infinity. Arrows going down are going to be negative infinity. Okay. And then what number should we put for the top of the graph if the range is always the Y value? +1. The top of the graph is +1 because we always use the Y coordinate. So bottom of the graph, negative infinity. Top of the graph is +1. Should I use a bracket or a parenthesis? Can I touch the point or not touch the point? I use a bracket because I can touch the point with my finger. So the range means these are Y values that are included. If I can touch the point with my finger, then that's a Y value that is included. Okay. All right. Increasing and decreasing intervals. These are both X values. So X values. X values that make the function slant down, X values that make the function slant up. Right? So the first thing I'm going to do is I'm going to figure out what the vertex is. What's the vertex for this one? 5, 0. Yeah, there's a number on the end that is not written, so it must have been a 0 because that's the only number you cannot write with a plus sign, and it doesn't matter. So +5 and 0 is the vertex. And then because these are X values that I'm using, that means I'm going to focus on the number 5. Okay. So I'm going to put my stick figure right here. And he is starting at a left arrow. What number is a left arrow? Negative infinity is a left arrow. And is my stick figure walking uphill or downhill? He's walking downhill. And he walks downhill until he gets to the vertex, which is at the number 5. And then at the vertex, he switches directions, and now he is walking uphill, so he is increasing. And he increases all the way to a right arrow. What number is a right arrow? Infinity. Okay. So the word decreasing is sandwiched in between two numbers. What are the two numbers? Negative infinity and 5. Okay. So negative infinity, that's an infinity, so it gets a parenthesis. The 5, I put a bracket if it works for the definition. I put a parenthesis if it doesn't work for the definition. Okay. The definition of decreasing is he is walking downhill. So when he is at 5, is he walking downhill? No, he's not walking downhill. He's in between. So I put a parenthesis. Okay. The word increasing is in between what numbers? 5 and infinity. Okay. Infinity always gets a parenthesis. We never have to wonder about that one. We put a bracket if it's true for the definition. We put a parenthesis if it's not true. The definition of increasing is that he's walking uphill at that number. When he's standing right here, is he walking uphill? No, he's in between uphill and downhill. He's not one or the other. False. So parenthesis, parenthesis. Okay. How do your brains feel about everything so far? Terrible. What half the notes did you not get? This part? This part that I'm holding for you right now? That you're not writing down? Once you're done writing that stuff, go ahead and flip the page. All right, we have another increasing and decreasing. So let's write the vertex. What is the vertex? 3, -2. I agree. So we got +3, -2. Okay. All right, so we're going to put our stick figure over here. We know that increasing and decreasing is always the x values. So Quentin, ready? All right, what do we have for the number for a left arrow? -infinity, okay. And our stick figure is going to start walking, and which direction is he walking? Uphill. He's walking to the right, he's walking uphill, which means he's increasing, and he increases up to the mountaintop. And what number is the mountaintop? 3. And then after he hits the mountaintop, which direction is he going now? Down. He is decreasing, and he gets to the right arrow. And what number is the right arrow? Infinity. Okay. So the word increasing is between what numbers? -infinity and 3. Okay. Always a parenthesis. When he's standing at the very top, is he still increasing when he's standing at the very top? No. Okay. Decreasing interval is in between what numbers? 3 and infinity. Okay. Infinity always gets a parenthesis. When he is standing at the very top, is he going downhill? Nope. He's in between. Okay. The next two, we have maximum and minimum. We learned from absolute value graphs that the maximum is going to seem like a mountaintop. And the minimum is going to seem like a valley. You only have one or the other. You do not have both in these graphs. So if you look at the first picture, example number 5, I'm sorry it printed so light, but here's our equation. Does this graph have a maximum or a minimum? It has a minimum. It has a valley. So for the maximum, we're going to put none. The minimum or the valley is the same point as the vertex. So can somebody tell me what the minimum is? -1, -7. Perfect. All right, for the next one, does it have a maximum or a minimum? It has a maximum. It has a mountaintop. It does not have a valley, so we're going to put none for minimum. Whenever you have one where the answer is none, where it doesn't have that answer, don't leave it blank. Write the word none. If you leave it blank, it looks like you don't know. If you write the word none, you show that you know that there's just no answer there. Okay. Where is the mountaintop? What are the coordinates? -5, 10. Easy. Okay. X-intercepts and Y-intercepts, where the graph crosses the X-axis, where it crosses the Y-axis. Here we have to graph this on Desmos. So let's get our Chromebooks out. You're going to need them for the assignment today anyway. So go ahead and get your Chromebook out if you don't have it out already. Yours is dead. Do you have your cell phone? You can do this on your cell phone. Actually, if you want to, here, Addison, it's a little bit easier to use your Chromebook. You can use my plug. Okay. So we're going to pull up Desmos. And the equation is y equals -pi. Anyone know how to spell pi if it's not dessert, if it's math? Pi. So you're going to type pi. It's going to put the pi button up there for you. -pi. And then we've got parentheses x plus 2 squared. So we're going to do shift 6 and then put the 2 squared, x plus 2 squared, and then plus 7. There's our graph. And we've got x-intercepts. We got some decimals there. So my x-intercepts are at -3.493 and -0.507. And I'm writing them like points. So that's how I wrote them. Okay, and then let's go ahead and find the y-intercept also. So 0, -5.566. Quentin, you got it? Quentin, you got it? Quentin, you got it? You got it? Yeah. You a little sleepy over there? We need to go back and like have nap time like they used to back in the day in school. Back in like when we were, I don't know, kindergarten, preschool. When did they last have nap time? Kindergarten? Those were the good days, weren't they? Okay. Everyone have their intercepts written down? Quentin, you got them written down? Because your eyes were closed. So seems like maybe you wouldn't have them written down. Okay. Let's go ahead and turn the page. Boop. Oh, look, we got some more. Square root. We got to type that in on Desmos. Anyone know how to type a square root in on Desmos? Yeah, you can use the keyboard Or if you're a fancy computer programmer, you want to know the other way to do it? Type SQRT. SQRT. Square root SQRT. Isn't that cool? No? I don't know. Okay. Square root 2 SQRT. Square root 2 x minus 1 squared minus 8. And we'll get our x-intercepts and our y-intercept. It's almost like you guys think this is boring. Is it because this is so easy? I think it's boring because we already know how to do all this stuff? Yeah? Yeah. That's a good question. I am not sure. I'd have to look it up. After I make you guys an answer key, I will look for that. And we shall see. Continuity, the graph is continuous. If you can trace it with your finger and not pick up your finger. Quadratic functions are always continuous. It's going to be a little while before we find a graph that's not continuous. So this is kind of a boring question for a little bit. End behavior is, again, it's just us describing our arrows. So left arrow, we have a left arrow that goes up. We have a right arrow that goes up, but we're not English people in this classroom. We are math people. English people would write something in words. Since we are math people, we write this in symbols. So we're going to say as x goes to negative infinity, this is how I say the left arrow. As x goes to negative infinity, we're using an x because we're talking about the left. Left versus right, we're using negative infinity because we're specifying the left. The left arrow, if I want to say it goes up, I'm going to use y, and I'm going to use positive infinity. The left arrow goes up. If I want to talk about the right arrow, I'm going to use x, and I'm going to use positive infinity. The right arrow, and then I'm going to say this one goes up as well. Y goes to infinity. So the left arrow goes up, the right arrow goes up. And then we want to say for this other type of picture that the left arrow goes down and the right arrow goes down. Destiny, you getting this written down? As x goes to negative infinity, so this is how we say left arrow. The left arrow, y goes to negative infinity, goes down. And the right arrow goes down. The right arrow goes down. All right. How are your brains doing? I haven't put end behavior on a quiz. I haven't put it on a test, I don't think. But it will be on one at some point. So if you have questions, make sure you ask them, because I can keep talking about it, but at some point it will be on an assessment.